Okay, so we are now on page 319, areas of circles and sectors. Now, the exploration is pretty much introduced in the same manner as before, so I'm not going to bother going through this because it's pretty much going to be the same idea. The only difference is that instead of using the circumference of a circle, we're going to use the area of a circle because now we're going to talk about areas of circles and sectors. Now, if you don't know what a sector is pretty much only a part of the circle. It's, for example, if you have a cake and you're taking a round cake, I would say, and you're taking a slice out of it, okay? If you have a round cake like this, and you're going to take a slice out of it, this little piece right here is one of the two sectors in the circle. Where's the other sector? Well, the remaining piece. So that's a sector and that's a sector. And the sector is all have to do with this angle, the central angle that is right there. So as far as the exploration, we're not going to worry about that for now because it's pretty much the same thing. I want to get to the main point of this. We are going to do part of exploration 2 as an introductory to how to use the equation. Okay, where I want to go first is, let me tell you guys where the problems are going to go. If you turn to the next page on page 320, problem number 1 is going to go right there. So that's at the bottom of page 320. Turn to page 321. 2 is going to go up here, and we're going to skip that population density for now. We don't really need to know about it right now. And then right at the bottom, you're going to do number 3. Now here, it's very important for you guys to look at the equation for the area of a circle. The area of a circle is equal to pi multiplied by the radius quantity squared. Okay, this is on page 321. Now on the next page, on 322, we're going to have problem number 4 right there. Now this is where I want to start off with. Now, this equation, confusing. Don't look at that one. Okay, I want to focus on this equation. Now this equation is the same thing as the one that we just used for the arc length of a circle, but instead of the arc length, we're going to use this for the sector. Now, instead of having the circumference of a circle here, we have the area of the circle. Other than that, everything is pretty much done exactly the same way. Now, let's go back to the second part of the exploration on page 320. This is a really nice problem I want you guys to look at. Okay, so here's what you got. These devices right here, okay, they are 400 meters long and they stand across a crop, a circular crop, and with time, they rotate around, making sure that the whole field gets enough water for whatever plantation it is that they're trying to grow. So the radius of this circle happens to be 400. Now the rate that this thing turns, it turns at a rate of once every 3 days. So it makes a full turn in 3 days. That means that in 1 day, it's only going to turn 1/3 of the whole circular crop. And they want to know, find that area. So in other words, you have a circle and it makes only 1/3. Okay, so that 1/3 probably looks something like this. Okay, so third, third, third. So they want to know what is the area of this right here going to be. So we do know the radius. The only thing that we need to know is what is this angle? So it's very easy to figure out what that angle is because this is going to be 1/3 of 360 degrees. So 360 times 1/3 is 120. So that degree right there, oh, sorry, can't even see it, is 120 degrees. And we're going to use that to find the area. So now, if you remember the equation for that, that is on page 322. the area of the sector in this case is equal to the angle over 360 times the area of the circle pi r squared. We know the radius of this thing to be 400. All we got to do now is plug numbers in because we are looking for the area of the sector. So the angle is 120 degrees over 360, and that's going to be pi times the radius quantity squared. The radius, 400. So after this, all you have to do is just simplify. This and this divides out. 12 and 36 are both divisible by 12. So 36 divided by 12, that's 3. Okay, so that reduces to 1/3 times pi times, now 400 square, it's a huge number. Okay, so then what we're going to do is we're going to multiply that by pi, and I'm using this in the calculator, and then divide it by 3. So the area of that sector is pretty big, 167,551.7 meters. So meters square. It's a big area. Okay, let's go ahead and get started with the following examples. So the first example is actually going to be right there. Okay, example 1. Area of a circle with a radius of 2.5 centimeters. So area of a circle, if you remember, we already said it was going to be pi r squared. The radius is 2.5. So area equals pi times 2.5 quantity squared. Now, if you put this in the calculator, 2.5 quantity squared, this is going to be 6.25 times pi. Okay, so it's approximately 19.6. Now, they want to know the diameter of a circle with an area of 113 square centimeters. So I'm going to find the radius and then just double it because we know that 2 times the radius is equal to the diameter. So I'm going to look for the radius using the same equation. Area equals pi r squared. The area is 113.1. I need to find out what is going to be the radius. So my goal is to solve for r. So before I do anything, I have to get rid of the pi. How to get rid of pi? You eat it all. Get it? Eat it, pi? I know. I know you guys miss my lame math jokes. Okay, so I get approximately 36. Now, when I want to solve for r, I have to do the square root of r and the square root of 36. So I know the square root of 36 is already going to be 6. So since the radius is 6, that means that the diameter is twice of that. Well, I made a mistake. Can I use capital letter? So diameter is equal to 12. So if at any time you guys need to go back and see how I did this again, just stop the video, go back and replay it. Okay, example number 2 has actually 2 parts to it. They want me to find the areas of the sectors formed by the following angle, U, T, and V. Okay, so there's 2 sectors, the inner sector and then the outer sector. Now for the outer sector, all you have to do to find that angle is subtract 360 from 70. Well, 70 from 360. So this angle right here is 290. So the equation is going to be exactly the same. The only difference is going to be just the angle. So the area of the small sector UV is going to equal 70 over 360 times pi times the radius of 8 squared. Now I get to simplify all of that. Now let's see, that divides. 8 squared, that's 64. So that's 7 pi 64 over 36. Now I'm very sure that 64 and 36 are both divisible by 4. So 64 divided by 4, that gives me 16. So I'm going to reduce both of these by 4. Okay, so that's going to give me 16. That's going to give me 9. So 16 times 7, that's going to be 112 pi over 3. Now, keep in mind, this is only the approximation. This is going to be the next approximation. 112 times pi divided by 3 gives me about 117.3. And this is inches squared. The next thing we got to do is we need to find the sector of the other part. Now, this is the interesting part. I'm not going to say that this is called sector UV. I'm going to say it's called sector USV. Why? Because it kind of tells you the directionality. So the equation is exactly the same thing. The only difference is that instead of 70 degrees, it's 290. You see how they're the same? The only thing that changed was the angle. Okay, so then now what we got to do is we got to simplify this. Now, okay, so we still have this. Actually, let me simplify that. The 64 and the 36 are still divisible by 4. Okay, so 16 times 29, that gives me 464. Oops, that's it. Over 9 pi. And then plug all of this into the calculator, and you get about 161 point, well, about 162 if you round to the nearest inches squared. So this is the area of the small sector. This is the area of the large sector. And if you add them all together, it's the area of the whole thing. Okay, let's move on to problem 3. Okay, it says find the area of circle V. They give you the area of the sector and the central angle. We're going to use the same area, the same equation. So the area of the sector, in this case TU, is equal to 40 over 360 times pi r squared. Now we want to find the area of the circle. So I want to solve this for pi r squared. So let me simplify this part right here. Those divide out. 4 and 36 are both divisible by 4, so this gives me 1/9 times pi r squared equal to the area of the sector, which happens to be 35. That's this one right here, all this. So to solve for pi r squared, you have to multiply both sides by 9. So I'm going to multiply this by 9, multiply this by 9. Those are gone. And 9 times 35, That's equal to 315. That's equal to pi r squared, which is the area of the circle. Okay, so the area of circle V is 315. Okay, so this right here has a lot of steps. Okay, what they want us to do is they want us to find what is the area of the wall. So you pretty much have a wall here, and you have a window that's going to cut into the wall. So the area of the wall, or we should say, the area of the wall with the window, can't spell window, is pretty much a rectangle, 36 times 26. 10 plus 16, that's 26. So 36 times 26. Okay, so the area of that is 936, but that is assuming that we're going to paint over the window. So what I need to do is I need to find the area of the window so that I can subtract the area of the wall. Area of the wall minus the area of the window is going to give me the area of the paint of the surface that I'm going to be painting. Now, here comes the problem. The area of the window is made up of two parts. It's made up of this rectangle, and it's also made up of one semicircle. So we need to find out what that is. Now, the area of the window, that's easy for this bottom part right here. This distance is 16. The distance from here to here is 16. And the distance from here to here is 16. So 16 times 16, I don't know what that is. 16 times 16, that's 256. Now, to find the area of the semicircle, okay, I'm going to find the area of the circle and times it by 1/2. Now, here's the thing. The radius. If the diameter is 16, that means the radius is 8. And I just continue to simplify. 8 squared, that's 64. 64 divided by 2 is 32. 32 pi. 8 squared, 64. 64 divided by 2 gives you 32. So now, I need to approximate what this is going to be. So 32 times pi, enter, then plus 256. That's going to give me approximately 356.5. Now that's the area of the window. Now what we got to do is we need to subtract this minus this to get the area of the wall that we're going to paint. So 936 subtract 356.5. And then that's going to give me my final answer. So the total area is 579.5 feet square. Okay, so what you guys are going to be doing now is you guys are going to be working on the extra practice and the online homework. Now, in terms of the extra practice, there's a problem I don't want you guys to do. Turn to page 323, and I want you guys to cross off number, number 9. You don't need to do that one, okay? Please make sure you guys do the online homework that is assigned to this one, and stay tuned for our next Zoom meeting.